In this example, we have a situation that's fairly similar to the previous one. We have the integral of x times the square root of 2x minus 1 dx. In the previous example, we just had integral of square root of 2x minus 1 dx. We still have a function composition, and 2x minus 1 is the inside function, so we're going to let that be our u. Taking the derivative of that and rewriting it in differential form, we get du equals 2 dx. Now we don't have a 2 dx in the original, so we're going to divide by 2 to end up with 1/2 du is equal to dx. So the 1/2 du is going to swap out for the dx, u for the 2x minus 1. Now we still have that x on the outside, and the way we're going to get rid of that is by solving the original expression u equals 2x minus 1 for x instead of for u. And when we do that, we get x is equal to u plus 1 over 2. So now we can start to rewrite. We get u plus 1 over 2 for x. We get u to the 1/2 for square root of 2x minus 1. And then we get 1/2 du for dx. We can work on that just a little bit more. We have the two 1/2s in there, so we'll bring those out and get 1/4. Then I'll put the u to the 1/2 next. Then multiply that by the quantity u plus 1 du. And at this point, the easiest thing to do would be to distribute out the u to the 1/2, and we get 1/4 integral of u to the 3/2 plus u to the 1/2 du, which we can now begin to integrate. So we still have the 1/4 on the outside. Now we're going to get u to the 3/2 divided by 3/2, or 2/3, u to the 5/2 divided by 5/2, or 2/5 times u to the 5/2. Then u to the 1/2 will become u to the 3/2 divided by 3/2, or 2/3 u to the 3/2. And we have the plus c. The plus c could go on the inside of the parentheses, but that's just going to be multiplied by 1/4 and give us yet another constant. So we'll just leave it on the outside right now. It refers to some constant value that would be added or subtracted on at the end. All I need to do now is to simplify fractions, distribute the 1/4, simplify fractions, and swap in the 2x minus 1 for u. So 2 over 20 is 1/10. U is 2x minus 1 to the 5/2. 1/4 times 2/3. 2/12 is 1/6. And that's times 2x minus 1 to the 3/2 plus c, and we're done with that. Alright, so I will give you an example and you can work through that. So I'd like you to try the integral of 2x minus 1 over square root of x plus 3 dx. And I will give you can pause the video, try that out, and I'll give you the answer in a few seconds. Okay, so what you should get as a result of that is 4/3 x plus 3 to the 3/2 minus 14 times x plus 3 to the 1/2 plus c. If you got that, you can feel free to move on. If not, I will work through that solution now. So the first thing that we would do is rewrite that as 2x minus 1 times x plus 3 to the negative 1/2, and from there we can see the function composition has an inside function of x plus 3, an outside function of x to the negative 1/2. We'll let u equal x plus 3, so that the derivative of that would just be 1, and in differential form, du is equal to dx. So now we have the x plus 3 becomes u to the negative 1/2, dx becomes du. The only thing that we need to worry about is the 2x minus 1. So we solve the initial u equals x plus 3 for x. X is u minus 3. And so 2x minus 1 would be 2u minus 7. We can now rewrite as the integral of 2u minus 7 times u to the negative 1/2 du, and we're ready. We'll first distribute and then begin integrating. 2u times u to the negative 1/2 gives me 2u to the 1/2 minus 7u to the negative 1/2 du, and we're ready to begin. 2u to the 1/2 becomes 2u to the 3/2 over 3/2, or 2 times 2/3 u to the 3/2. 7u to the negative 1/2 becomes 7u to the 1/2 divided by 1/2, or 7 times 2u to the 1/2 plus c. Simplifying and swapping back in x plus 3 for u, we get 4/3 x plus 3 to the 3/2 minus 14 x plus 3 to the 1/2 plus c.